Okay, so we just do a lab about what? A lab about what? Waves or periodic motion. Okay, so today we're going to start actually, talk about the terminology or the new words we need to know for this unit. By the way, just so you know, this unit is usually completely distinct from everything before and everything after. It doesn't almost involve anything with kinematics. It doesn't involve forces. It doesn't involve what? What's the third unit? The one we have a test on tomorrow? Energy or work. That's why so many physics teachers actually cover it at the very beginning of the course. They finish, they're like, let's get this over with. And then they start with what? Kinematics. I was like, no, kinematics, we should all start with it because it introduces you to math and physics in a good way. So let's start. So can someone give me another name for wave? There are three popular names for them. Can someone give me a name for wave? What name did I use when it was going back and forth? Starts with a C. Periodic motion is the what? Is the behavior itself. But what's the word wave itself? Current? Not quite. Cycle. One of them is cycle. Okay. What do molecules do? Vibrate. Vibration is another one. How many people have heard the word oscillation? Oscillation. Good. No, what's again? If it keeps turning, sure. Turn. Oscillation also means what? Vibration or cycle or wave. They love to use that with what? With first year physics. So there you go. Sorry. Sorry. Cycle, vibration, oscillation. By the way, don't say oscillation. It's a C, just like the word sine. Okay? So oscillation. Get used to this word, oscillation. I am not going to ask you to use oscillation in grade 11 or in physics, but I can guarantee you, if you go to first year physics, engineering, or science, half of your questions are going to have the word oscillation in it. It just means vibration or cycle. Okay? They all mean the same thing. A wave consists of cycles, it consists of vibrations, it consists of oscillations. Like, for example, you could have said the mass was what? Cycling back and forth, or what? Oscillating back and forth, or vibrating. Yes, you got it now. Okay. So what is a wave? Okay. A wave is any phenomenon. How many people know what the word phenomenon means? Phenomenon just means an event, a physical event, a chemical event, a social event, a phenomenon. Okay? Any phenomenon that I have to be careful here. In grade 11 and 12, we always assume that the wave what? The wave what? Perfectly repeats itself. Is there any wave that really could perfectly repeat itself on its own? Eventually, what would have happened to the pendulum? It would have just what? Stopped or died off, okay? By the way, even when we have a dying off or a decaying wave or a decaying periodic motion, we could still call it what? Wave. But the problem is the mathematical analysis then gets what? More complicated. Because what's happening to the strength? It's going what? It's going down, shrinking. No, we're gonna assume it's a perfect what? By the way, what am I sketching with my finger here? How maybe I've done grade 11 math, MCR 3U. What kind of functions did you do? You did quadratic function, you did exponential function, and then you did what? What do you call the functions that go like a wave? Cosine and sine, yes. Sinusoidal function, okay, or sinusoidal function, okay? So perfectly repeats itself within a certain time interval. That's why we calculated the time with the lap function. A wave always have to look like an actual physical wave? No. Anything that repeats itself is a what? Is a what? Is a wave or is a periodic motion. I think I replaced it with. What are examples of periodic motion? Well, literally, you showing up to class every day is what? Is a periodic behavior or a periodic motion because it takes a period to repeat itself. However, here are some examples. Daily rotation of the earth. Daily rotation of the earth. Does anyone know what? Has anyone ever heard of something called simple harmonic motion? Just raise your hand. This is nothing but a big word for spring motion. If you stretch a spring and leave it, what happens to it? Does it stay there? What happens to it? Exactly. That's called a simple harmonic motion. Okay? We do a lot of it in grade 12 physics. So how many examples did I give you here? 2. I gave you a third one. Do whatever you want with the third example. You can come up, as long as it repeats itself, it's a perfectly fit example. So the first one is daily rotation of the Earth. The second one is simple harmonic motion, or you can say spring motion. The third one, you can come up with whatever you want. You wake, I mean, waking up every day at 6 a.m. is a what? Is a periodic motion. Okay. Oh, sorry. Okay. What are the properties? Come on, everyone, wake up. What are the properties of waves? Okay, everyone. Every wave has how many properties? How many? I'm only gonna teach you 4. The reason is the fifth one is actually okay, but I'll discuss it with you. The first one. So any wave or any phenomenon that repeats itself, you can always talk about 4 things it has. Every wave, I don't care how fancy or basic it is. 4 things or 4 features. Feature number 1, frequency. Feature number 1, frequency. Feature number 2. Feature number 2. Period. Okay. Feature number 3. By the way, how many people have heard those terms in math courses? Yes. Physics and math are really the same at the end of the day. This one, I know you heard it in a math course when you did sine and cosine function. How many people have heard of amplitude? Yes. Amplitude. Who would like to guess the fourth one? I'll give you a hint. Okay, 1 second. I'll give you a hint, but you get the first hint. When you learned grade 10 science, do you remember the light unit, Roy G, Bev, and all that? Light is different with what? Wavelength. Thank you. Yes. No, because it has hand up. Wavelength. Frequency. Question, everyone. When something is frequent, what does that mean? Happens what? Regularly. A little or a lot? Thank you. So frequency is what? Frequency is the number of times something happens, but it's important. Within 1 time unit. Okay. I realize that this single time unit way is weird, because in physics, what's the single time standard unit? Yes. So we will always define it now. The frequency of something is the number of times something happens in one what? In 1 second. For example, is this periodic motion? Is this periodic motion? Are they the same periodic motion? Which one happened more within the same time? The second one. There you go. The second one had more frequency than the first one. That's it. That's what frequency is. So the number of times an event repeats itself within a single time unit. If you want to write second next to that, like here, second, feel free. Basically, it's how many cycles you can do in 1 single second. This is a cycle. When something perfectly repeats itself once, only once, no more, no less, that's a cycle. Okay, so it's how many cycles you get per 1 second. By the way, are you always guaranteed to get a whole number or an integer number of cycles every 1 second? You could, or it might be a decimal. Who cares? It's just the number of cycles, whether it's a decimal or a full number. Cycles is basically cycle. 1 single vibration, 1 single one, not half, single one. Okay. Any guesses? We did talk about it, and it's actually in your notes. Uppercase or lowercase, as we said many times, because uppercase F is for forces. This is that. Same thing. Number of times something happens over what? Time it takes. Well, this is way too many words, What's the official math equation? That's it. Number of events over delta t or time length. Done. That's it. Okay. All right. Does anyone know how we measure frequency? It's a unit that hear a lot when you talk about processors and radio stations. Yeah. Hertz. Hertz. Gustav Hertz, an Austrian physicist. So how So frequency, period relation. Okay, so what was the frequency we got for the shaking? Come on, what was the frequency value we got? How much? 4 times 10 to the, come on everyone, eyes on the screen. What was the value for the period in scientific notation? Before we did 2.5, 2.5 times 10 to the negative. Okay, how can you multiply, everyone? How can you multiply in your head these two scientific notation numbers? Well, let's think about this. Can you put these two together? Yeah, you can always change the order as long as you don't put anything up or down where it did not used to be. What's 4 times 2.5? What's 4 quarters? $1. So what's 4 times 2.5? 2.5, 2.5, 2.5, 2.5 is a full 10. This is a full 10. Okay, 9. What do you get when you add those two exponents? What do you get? You get -1. What's the power? Sure. 1. 1 minus 1. No tricks. Trust me. 1 minus 1. 0. What's any number to 0? So what do you get here? Any number other than 1. Other than 1, if you multiply frequency, no, as long as you're doing the same event frequency, same event period, you have got to get a perfect one. If you forget rounding, that's why I use these ones, because there were no rounding. Perfect 4, perfect 2.5. So what's the relation between frequency and period? The product of frequency and period is always a solid one. So basically, mathematically, this means this. Can someone tell me how many variables are in this equation? Variables. 2, which means what? If you know one, you must what? You must know the other. Because if I give you a frequency, you're like, oh, sweet, I can just what? I can just divide out the time or the period, sorry, the frequency and get the period, and vice versa. No. F times T must be 1, which means what? That's why when one goes up, the other one what? Um, give me two numbers that multiply up to 100. Any two numbers you want, as long as they're integer. 50 times 2. 50 times what? I'm going to give me 2 numbers that multiply also to 100. So this one. When you fix the multiplication, that means what? Whatever goes up, the other one what? Goes down. Okay, kind of like energy bars. Kind of like, but the energy bars do it in an addition. This does it what? In a multiplication. Yes. Which means from here, we can reinvent or rearrange into 2 different equations. F 1 over T equals what? 1 over F. Which means what? If you know one, just flip it to know the other. Okay, how many things are we done so far? 2. Frequency and what's the third one on the list? Not that it's any important than the fourth one, but what's the third one? Amplitude. How the size of the wave, the height or the size of the wave. Awesome. Okay. Basically, it's how much the wave shoots up or sinks down from the what? From the what? Neutral. What's another name for neutral? Original. What's another name as well? Because it's a word that I use twice when I call the temperature at the end. Equilibrium. The book's called the equilibrium position because it's the position where the wave is perfectly, where the spring is perfectly at the center of the shaking. Equilibrium. I'm not going to use it much. You should know it's there. If I show you a first year physics textbook, you guys see that most of the time they don't call it neutral. They call it equilibrium position. Equilibrium position. Yes. I'm going to use it more in grade 12 than grade 11. By grade 11, I'm just going to stick to simple words, neutral or center. Okay. Any ideas for the symbol for amplitude? Or small? Thank you. Yes. Although, sorry. Well, what do you think? Everything in this unit is a what? Is a scalar as well. Okay, so if I am listen up on your quizzes, I will show you a wave, and I will ask you to measure the wall. No. What did we just call it? Don't worry, I'm not. I'm gonna give. Okay, I'm always gonna give you a wave. Listen up. Behind it, like on a grid, so it's easy to see the scale. Like basically, I'm gonna give you a sine function. I'm also gonna give you a y-axis and x-axis because all the numbers and the intersection of the grid and everything. Okay, what do you call this line? The neutral position or the graph? I'll call it the central line. But you're right. It's also the neutral position of the what of the spring. All right. Go ahead. Come on. Central line. Central line. Okay. There. Pick any two you want out of it. All of them. Remember, amplitude is the physical size of the wave. Okay. The other thing, everyone, what's the unit? Listen up. Okay. It's the separation between. Okay, everyone, be careful. Be careful about wavelength. It's from one point on the wave to another what? You have to go back to the what? The exact same identical point. What does that mean? If you start at one peak here, you have to go to another what? Peak. If you start at one bottom, you have to go at the next what? Bottom. You have to go back to the exact same nature of a point or a location. Okay? As long as you go the same distance, it doesn't really matter which point you pick. You just have to go. And again, you have to only go how many identical points away? Just what? This one. If you go two, that's two wavelengths. If you go half, that's half a wavelength, and so on. It's the way I always understood wavelength. It's either a compressed or how what? Compressed or straight. Compressed. If it's compressed, is the distance between my hands big or small? So that's a small wavelength. That's jumping from how about now? That's a stretch wave, and a high or a huge or a big wavelength. Yes, you got it. I never looked at it except in this way, and it just always made sense to me. It's how compressed or okay. The Greek letter, yeah, everyone. There's a B in the name, but just like when you say what lamb, you don't pronounce the B, so it's lambda or lambda. Greek way probably saying it is lambda. No B, no B, no B, no B. Like saying limb or lamb, so on. Okay? All right. Where can you measure the wavelength here? Remember, you have to choose a point and you have to jump to the next one. Identical point. Give us one central line again. There we go. Yeah, I picked 3 ones, but I did pick this weird one, which unless it's on an intersection grid line, please don't use it. Go ahead. Oh, lambda, lambda, lambda in each. All right. Boom. Wavelength is meters. Unlike frequency and period, amplitude and wavelength do not have what? Their own dividing equation. Like there's not one that usually has lambda on the left side and everything else on the right side. Sure. Do you have a blank slide? again, you do not. You just need to know that those two have equations. The others two don't. That's okay.